Hi guys, today we're going to actually take a break from graphing and we're going to learn about the inverse trig functions and how to use them to solve problems. I'm going to actually first show us what the graph of an inverse trig function looks like. I'm going to do the one for sine. So I'm going to start by just listing out the original sine values. So we have theta, which is like the x, and then we have sine of theta. I'm going to start with just the same key points that we started with when we were normally graphing sine. So normally graphing sine, we go from 0 to 2 pi, and we increase by pi over 2. So the next one would be pi over 2, and then we'd have pi, and then I did not leave myself room, and then we'd have, this is 2 pi over 2, so then we'd have 3 pi over 2, and then lastly we would have 2 pi. And then remember to think about what the y values would be. Instead of going back to your unit circle, you can also just think about what the graph looks like. It starts at the midline, it goes up, it comes back down, and it goes this way. So I always think about that its original value is 0, and then it goes up to 1. It comes back down to the midline at 0. It goes down to -1, and then it ends back at that midline. So these are the original sine functions, and this is just one cycle. Remember, it does go backwards forever into the negative angles. It would keep going forwards forever. So I'm going to then think about how we can create an inverse from this. Now remember, we've actually done inverses, I feel like, a million times this year. How we have found inverses graphically, or when we have a table of values, is we just take those table of values and we swap the x and y. So I'm going to take these and swap them to create some new points that would be on the inverse. So if the original was 0, 0, the inverse will have 0, 0. If the original was pi over 2, 1, the inverse would be 1 and then pi over 2. If we had pi 0, the inverse would be 0 pi. And then 3 pi over 2 would be -1, so that's -1, 3 pi over 2. And then lastly, 2 pi 0 would turn into 0, 2 pi on the inverse. And then if we think about what this graph looks like, so on my x-axis, these are now my x's. I don't need a whole lot on my x-axis. I just need to go to -1, I'm going to put right here, and then +1 I'll put right here. And then on my y-axis, I have 0, and then I have pi over 2. I'm going to call this line pi. So then this line would be pi over 2. This one would be 3 pi over 2. And then up here we'll have 2 pi. So I'm going to plot the points I have, and then I'll show you how we can actually continue the pattern to do more. So we would start with, we have a point at 0, 0. That's just the origin. And then we have a point at 1 comma pi over 2. So right 1 up to pi over 2. 0 pi, so that means left or right 0, and then just go up to pi. -1, we're at 3 pi over 2. And then at 0, we're back at 2 pi. So left or right 0, up to 2 pi. So then if we connect these, it's kind of like a sideways sine wave. And this pattern would kind of just continue on and on forever. You'd have a point here. You'd come back to the center. It would continue going this way and then come back to the center, and this pattern would just keep on going. Now the problem with this is not a function. Okay? The original sine graph is a function. Okay? This would be a function. It passes the vertical line test, but this one does not pass the vertical line test, so it's not a function. So what we do for inverse graphs is we restrict what part of the graph we're looking at. So instead of looking at this whole thing as the inverse of sine, we restrict it to just part of it that would pass the vertical line test. And that's going to be this little chunk right here. If we only use this part of the graph and everything else goes away, hide it, we now have an inverse sine function that would pass the vertical line test. And we'll see that on our paper at the bottom or in the middle. We can see what the inverse sine function looks like. And again, we're restricting it to just a domain of -1 to +1, a range of -pi over 2 to pi over 2, so that it ends up passing the vertical line test. And then we do the same thing for inverse cosine. If we take its original x and y's and switch them, and then restricted's domain. And then same thing for tangent. Tangent looks a little different though. Okay, so taking its original x and y values, those vertical asymptotes that we had on tangent actually become horizontal asymptotes on the inverse. And you can actually see this is just the one original cycle of tangent, because usually we do a cycle from negative pi over 2 to pi over 2 with our little snake in between it. So this is kind of just the snake turned to the side. So we're going to start by looking at what the ranges would be for our inverse trig functions. Okay, and we're just looking at the range because the range is what we're going to use to help us solve problems. So starting with the range for inverse sine. Inverse sine, we just looked at the range. The lowest to highest would be negative pi over 2 to pi over 2. Excuse the angry dog in the background. Including both of those. If we were to write that in degrees, pi over 2 in degrees is just negative 90 degrees. That would be negative 90 degrees to 90 degrees. Square bracket, including both of those. Cosine's range, you can see it. It's actually from 0 to pi. The lowest is 0, the highest is pi. 0 to pi, include both. And then if we were to write that in degrees, that would be from 0 to 180 degrees, because pi is equal to 180 degrees. Okay. Inverse tangent is actually similar to what it was for inverse sine. It's negative pi over 2 to pi over 2, but we actually have asymptotes at those lines now, so we don't actually want it to be equal to the pi over 2 and the negative pi over 2. So it's still negative pi over 2 to pi over 2, but just parentheses instead of square brackets. So then your sine would be very similar. It would be negative 90 degrees to 90 degrees, just don't include either side. And then cosecant is actually very similar to its reciprocal, and its reciprocal is sine. These two are related. So it's very similar to this one, except if we go look at our unit circle real quick, okay, cosecant is basically if we took the sine value and flipped it over. So we would have to take the y value and flip it over. So if we were to look anywhere from negative 90 degrees to positive 90 degrees, there's only one place where if we were to take the sine value and flip it over, we would get something that's undefined, and that is at an angle of 0. So cosecant's range is almost the same as this, except we want to exclude 0. So we would say we want to go from negative 90 degrees to 0, and then hop over 0, so we don't want to include 0. And then we'll go from 0 to 90 degrees. So we're just skipping over the 0, and we'll do the same thing here. We'll skip over 0, but just write it in radians, keeping it almost identical to the original sign. So that would be negative pi over 2 to 0, and 0 to pi over 2. Okay, and it's similar for secant. Secant, remember, is the reciprocal of cosine. So it's basically if you took the cosine, the x value, and flipped it over on a unit circle. So cosine goes from 0 to pi, which is 0 to 180. So there's only one place, if we look at all of the x values, there's only one place, if we were to take that x value and flip it over, we would get something that's undefined, and that's right here at 90 degrees. If we took 0 and flipped it over, we would have 1 over 0, which is undefined. So cosine and secant are similar, except we want to hop over 90 degrees because we don't want to include 90 degrees. So we would say it goes from 0 to 180, or technically 0 to 90. We'll skip over the 90 and not include it. And then we'll go from the 90 to the 180. And it's similar even when it's in radians. We'll go from 0 to 90 in radians, which remember that was pi over 2. 0 to pi over 2. Don't include the pi over 2 because it's undefined there. And then pi over 2 all the way to pi, which is that 180 degrees. And then cotangent is similar to tangent, which tangent was already similar to sine. If you look at it, tangent and sine are very similar. Okay, but cotangent we're going to use what we did for tangent, looking from negative pi over 2 to pi over 2. So basically looking backwards 90 degrees or forwards 90 degrees. And we're going to look to see, is there anywhere where if I do the cotangent, remember, is the x over the y, would any of those be undefined? So if I did the x over the y here, that's just 0. X over y here would all be defined, but right here, we can see it's actually not defined, because if I did 1 over 0, it would be undefined. So we're going to write similar to what we wrote for the sine and the tangent, but we want to make sure that we don't include 0. It's actually, if you think about it, it is the same as cosecant. It goes from negative 90 to 90, but doesn't include 0. Because if you look, it actually does, it is okay to have it at negative 90 or at positive 90. If I took the x over the y, it would just be 0 there. So it's okay to include 90, it's just not okay to include the 0. So it's identical to cosecants. Negative 90, don't include 0 because it's undefined there, all the way to positive 90. And then similar in radians, negative pi over 2, don't include 0 because it's undefined there. Okay, so we're going to be using these ranges on the back and our unit circle. So if you have a unit circle handy, we're going to need, because we're going to be answering some questions. Okay, so we've done inverse trig on the calculator for a while now. We actually did inverse trig literally on the day 1 when we learned about right triangle trig and the old SOHCAHTOA. We had done inverse trig calculations on the calculator to help us find angles. So the normal sine, cosine, and tangent functions have angles as their independent variable, meaning you plug in the angles and then you get the ratio as the output variable. Okay. Now, inverse trig functions are opposite of that. Arc sine, which is the same thing as inverse sine, arc cosine, which is the same thing as inverse cosine, and arc tangent have ratios as their independent variable, and then the angles is their dependent variable, meaning you're going to plug in the ratio and your answer will be an angle. Okay. So if we look at, this is normal. This is what we've done before. The input variable is the angle. Okay. So what we did for this is we went to pi on our unit circle and we found the cosine at that angle. So we went over to pi. We found the cosine was this x value of negative 1 here. So this is normal. We've done this already. Today we're working on going backwards. We're going to do inverse cosine, which is the same thing as arc cosine. And we're going to say this is the ratio, this is the actual cosine ratio. And our answer is, what was the angle? What is the angle that would give us a cosine of negative 1? So our job is to look in the correct range for what angle here would have a cosine of negative 1. So when we look at all these x values, all these cosines, there's only one that has a cosine of negative 1, and that's at pi, which is 180 degrees. So it's just kind of backwards from what we've been doing. Now the reason all these little circles are on here is I use these to help me think about what part of my unit circle I need to be looking at, because we are only allowed to look in these areas. We don't want to look in the whole unit circle. For sine inverse, we only want to look from negative pi over 2 to pi over 2. For inverse cosine, we want to look from 0 to pi, and so on and so on. So I kind of use this to help me remember which part of my unit circle I'm looking at. So if I look at the first one, arc sine, remember that's the same thing as inverse sine of 1/2. Okay, so what I need to be thinking about is this literally means what angle has a sine of 1/2. Okay, and we're only allowed to look backwards 90 degrees or forwards 90 degrees, because that is the range for inverse sine. So we need to be looking here or here on our unit circle for what angle has a sine of 1/2. And remember, the sine is just the y value. So I'm looking at my unit circle. If I look backwards 90 degrees or forwards 90 degrees, I'm looking for an angle that has a sine of 1/2. Remember, sine is just the y value. So I see a y value of 1/2 right here. The angle here is pi over 6, or 30 degrees in degrees, or 30 degrees in degrees. So it's either going to be 30 degrees, or if we want to write the radians, that would be pi over 6. This is the answer. The answer is the angle for these questions. Okay, for the second one says what angle, or inverse tangent of square root of 3. So again, similar to the first one, it means what angle has a tangent of square root of 3. And tangents range is similar to sine. It's also backwards 90 and forwards 90. So we can be looking back this way or forwards this way. Either of these two. For which one has a tangent of square root of 3. Remember, tangent is the y over the x of the points. Y over x. All right, so going to look at my unit circle, looking if I do y over x, which one would have a tangent of square root of 3? So y over x, all of these would be negative if I did the y over x if I went backwards. So it's definitely one that's in quadrant 1 for the positives. If I did this y over x, I would have 1 over square root of 3. If I did this y over this x, that would be 1. But if I did this y over this x, that would be my right one. That's square root of 3 over 1, which is square root of 3. So that's at either pi over 3 or 60 degrees, however you want to say it. Pi over 3 or 60 degrees. Okay, next up, inverse sine of negative 1/2. So this is another inverse sine like what we started with. Inverse sine, remember, you can only look backwards 90 or forwards 90. Okay, so we're looking for an angle that has a sine of negative 1/2. I'm not going to write this on every one, but you will get the idea eventually. What angle has a sine of negative 1/2? Remember, the sine is just the y value of the point. I forgot to write that on this one. So looking at all of those points for which one has a y value of negative 1/2. All of these y values are positive, so we're definitely looking down here. So I see one right here. Now, the most common mistake on this question, and I see it on tests, I see it on quizzes, is people writing down 330 or 11 pi over 6. We can't do that because we're only allowed to write down a number that's between negative 90 degrees and 90 degrees. We can't write down any number outside of that. So if I write down 330, I'm writing down a number that's outside of my range. So I want to make sure I write down the negative angle that is coterminal to this. So that would be negative 30 degrees, or you can say negative pi over 6. Negative 30 degrees, or negative pi over 6. And then I'm going to also remind you that we can't say 330 because that's not in the range. Can't say 330 degrees because it's not in the range. Not in the range. Goodness, I can't spell today. All right, let's do some on the right. We have inverse cosine. Okay, if you remind yourself what the range looks like for inverse cosine, it's kind of the top half of your unit circle. Inverse cosine is from 0 to 180 degrees, which is the same as 0 to pi. So we can look here for the angle. Anything on the top. Okay. So we're looking for which one has a cosine of negative root 2 over 2. And cosine, remember, is just the x value of the point. So looking from 0 to pi, looking at all those x values, all of these are positive, and we need a negative. So coming over here, this point right here has an x value that is negative root 2 over 2, and that's at 135, which is 3 pi over 4. And that is in the range for cosine, because cosine's range, remember, is from 0 to 180. So 135 would fit in there. Next one, cosecant. Cosecant, remember, is the reciprocal of sine. Okay, that kind of helps me remember where I need to be looking because its range is very similar to what sine's is. It's also backwards 90 to forwards 90. The only thing is it just happens to be undefined here, but we don't even need to worry about that because that point right there is definitely not going to have a cosecant of 2 root 3 over 3. So we should be looking for an angle from negative 90 to positive 90 that if we flipped over the sine value, if we flipped over the y value, sorry about that, would we get 2 root 3 over 3. Okay, so backwards 90 to forwards 90. If I look downwards, all of these are negative, so I'm not going to look down here. If I flip over these signs, they're still going to be negative. So I'm going to look up here. If I flip over this, well, that's not 2 root 3 over 3. If I flip over this, I'm not going to get a 3 anywhere, but if I flip over this guy, I would get 2 over root 3, and 2 over root 3 would rationalize to 2 root 3 over 3. So we're going to write down 60 degrees or pi over 3 in radians. Okay, and then the last one, we have arctangent. Arctangent is the same as saying inverse tangent. They are kind of synonyms of each other. And the range for tangent was similar to what it was for sine. Okay, it's also backwards 90 to forwards 90. It's just it happens to be undefined at this point and this point, which is totally fine because this is not going to be undefined there. So we're looking backwards 90 and forwards 90 for an angle that has a tangent of square root of 3. And remember, tangent is found by doing the y over the x, and you can just use the numerators for that. And it is positive, so that kind of says, well, it tells me it's definitely not in this quadrant because these would be negative if I did the y over the x. So if I did this y over this x, that would be 1 over root 3, which is not root 3. If I did this x over this x, that would be root 2 over root 2, which is 1, which is not that. But if I did this x over this x, I would get root 3 over 1, and root 3 over 1 is root 3. And that was at 60 degrees or pi over 3, however you want to say it. Okay, now that we've done a few just regular inverse trig questions, we're going to do a couple that are compositions. We've learned about compositions before. We actually did compositions in Unit 1, but we didn't do them with trig functions, obviously. For a composition, we're going to start by evaluating what's inside the parentheses. So I'm going to start by doing this right here. Inverse cosine of negative root 3 over 2. So since it's an inverse trig function, remember that means we have a restricted range. For cosine, it goes from 0 to 180, so looking at kind of the top half of the unit circle. And the cosine is the x value of the point. So we're looking for an angle on the unit circle that would have a cosine of negative root 3 over 2. So from 0 all the way to pi, looking for a cosine, an x value of negative root 3 over 2. None of those because those are positive. And then looking here, there we go, right there. And 150 is in the right range. So that was at 150 or 5 pi over 6. Equals 150 or 5 pi over 6, however you want to say it. Now for a composition, once you do the inside part and get that answer, then we're going to do the outside part. So now we're going to do sine of 150 degrees. Now this is not inverse sine, this is literally just sine. Meaning go to 150 degrees on your unit circle and find the sine. The sine value, remember, is just the y of the point. So I'm going to go on my unit circle all the way over to 150 degrees again and find the sine, which is just the y value. It's 1/2 equals 1/2. So this is the final answer to the question. The final answer is always the answer to the second part. You'll do the inside first and then you'll do the outside. Okay, looking at the second composition, again, I'm going to start with the inside and do that first. Inverse tangent of -1. Inverse tangent, remember, has a range similar to inverse sine. You're going to look backwards 90, forwards 90. Inverse sine just happens to be undefined at these two actual endpoints. So backwards 90 to forwards 90. And remember how to find tangent. Tangent is found by taking the y numerator and dividing by the x numerator. And it is negative, so that kind of helps me figure out where to look. Okay, so if we're looking backwards 90 and forwards 90, for where can I do the y divided by the x and get -1? So I'm not going to get a negative number by doing the y divided by x up here because these are all positive. But if I look down here, if I did this y numerator divided by this x numerator, that would be -1 over square root of 3, which is not -1. If I did this y numerator over this x numerator, I would get -√2 over +√2, and -√2 over +√2 is going to simplify to -1. So this right here is the angle, but we need to remember, we can't write down 315 or 7 pi over 4. We can't write either of those down. And the reason for that, remember, is because the range for tangent is -90 to +90. So if I, parentheses actually, so if I write down 315, well, that's not in the range. The range is only -90 to +90. So what we have to say instead is that negative angle that happens to be coterminal. And that negative angle for this one is -45 degrees. So you would say -45 degrees is the answer to this first question. And then I'm going to bring down the outside part. Okay, so now we're going to do the cosecant of -45 degrees. And notice this is not an inverse trig function. This is just go to -45 degrees and find the cosecant. Cosecant, remember, is the reciprocal of sine. So we're going to take the sine value at -45 degrees and flip it over. The sine value is the y, so we would look at doing 1 over y, flipping over y. So still at that -45 degree angle. Okay. Here's my sine, -√2 over 2, but we need to take that and flip that over. So if I flip that over, I would get 2 over -√2, and then we would rationalize that by multiplying by square root of 2 over square root of 2, times √2 times √2, and that gives us 2 square root of 2 over, this would become negative square root of 4, which is 2. And then this would simplify, and we just have square root of 2 divided by a negative, which is negative square root of 2 for our final answer. And then looking at our practice AP question, it says function f is defined by f of x equals the inverse sine of x. Which of the following statements correctly describes the value of f of square root of 3 over 2? Okay. So since this is an inverse sine function, remember where we're only allowed to look. Inverse sine means you can only look backwards 90 or forwards 90, which would be the same thing as backwards pi over 2 to forwards pi over 2. And then I'm going to go look. I'm going to go look and say, well, which angle would have a sine value of square root of 3 over 2 from -90 to +90. And remember, if it's a sine value, then this is technically we're looking for the y value of the point. So looking on my unit circle, backwards 90 to forwards 90, it is positive, so I know it's probably not any of these sine values. So I'm going to look up here. This point right here has a sine value of √3 over 2, and that is 60 degrees, which is the same thing as pi over 3. 60 degrees or pi over 3. Now looking at my answers, this first one says it's equal to pi over 3, so that one I don't want to cross out. That one looks good. This one says it's equal to negative pi over 3, which it was not. That had the wrong sign value. This one says it's negative pi over 3 and pi over 3, but again, it's not. It's only this one answer. And then this one says it's not defined because there's no angle that would give you a sine of √3 over 2, which is not true. We found the angle. So there's only one answer, and the answer is A. The sine of pi over 3 is square root of 3 over 2, and pi over 3 is also in the range of the function because the range only goes from -90 degrees to 90 degrees. All right, guys, hope y'all learned something today.